What we're looking at today are properties of quadratics, or characteristics of quadratics. Now, an axis of symmetry is the first thing that we're going to look at. An axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. Because the vertex of f of x equals a parentheses x minus h, close parentheses squared plus k, is the point h comma k. The axis of symmetry is the vertical line x equals h, because it's going to go right through the vertex. It's going to go straight up and down, right through the vertex. So that vertical line, x equals h, will be the axis of symmetry. Previously, you used transformations to graph quadratic functions in vertex form. You can also use this axis of symmetry and the vertex to graph a quadratic function. Because if we know it's mirror image on either side of that line, if I can get one side of it, I can mirror it over and get the other. So again, just like we've been doing previously, I'm not too focused on graphing because again, you can plug this in and actually get the graph. It's not going to tell you much of anything. But we do want the vertex and the axis of symmetry. Now the vertex is the point h comma k. Yes, but not quite. There's one thing that we do need to change with 3 comma 4. Does anybody know? Yes. Because remember, inside those parentheses, it's x minus h. So that h value would be negative 3, because really what we have inside the parentheses is x minus negative 3. Is really what we have inside the parentheses, because again, we're talking about it moving to the left 3. So our vertex is going to be the point negative 3, 4. And the axis of symmetry is x is equal to h. So for this here, it's going to be what? X equals? Almost not 3, but negative 3. Because that would be the axis of symmetry. And that's it. Now, I'm not going to require you to graph this, but if we were to graph this, well, we can use the vertex negative 3, 4. That would give us the vertex. And we know that the axis of symmetry is going to be this line going straight up and down at negative 3. Now I can just pick a point for x at negative 2 and plug it in. So we could say negative 2, parentheses, negative 2 plus 3 squared plus 4. And I'm just plugging this in. I just picked a point. Well, negative 2 plus 3 is 1. 1 squared is 1. 1 times negative 2 is, and negative 2 plus 4 is 2. So at negative 2, 2, we have a point. So that's one of our points. Now I could do the exact same thing for negative 1. So we could say negative 2, parentheses, negative 1 plus 3 squared plus 4. That would be negative 2, parentheses, well, 2 squared plus 4. 2 squared is 4 times 2 is negative 8, and negative 8 plus 4 is negative 4. So at negative 1, we have negative 4. Now we could do the same thing with 0. But at that point, we're going to get a number that is off this graph because 0 plus 3 is 0, or sorry, not 0, 3. 3 squared is 9. 9 times negative 2 is negative 18, plus 4 is negative 14. So we're way below. But because of the axis of symmetry, this point here, negative 2, 3, is a distance of 1 away from the axis of symmetry. So the point, if we were to do negative 4, would actually be negative 4, 3. This point here is a distance of 2, so distance of 2 over would be the other point. So this here would be the graph, because again, it mirrors across that line. Which is kind of handy because if I'm trying to find points to the left and right of the vertex, all I've got to do is find the ones either to the right or to the left, and vice versa, they'll mirror each other. Because if I find 3 to the left, the 3 to the right of it will be the same. Any questions on this here? Okay. So looking at this equation here, what would the vertex be? Negative 4, negative 2, h comma k. Again, really h, we're going to have to switch the value of h, or the sign of h, because since it's plus 4 inside the parentheses, it's going to come out as minus. If it's positive inside the parentheses, it's going to come out as negative. If it's negative inside the parentheses, it's going to come out as positive. And we take the k value as it is. Axis of symmetry. X would equal. That's it. Questions on this here? Vertex. Negative 1 and 0. Axis of symmetry. X is equal to negative 1. Any questions on any of this here? What would the vertex of this equation be? 2 and 5. And the axis of symmetry would be? And that's it. Questions on this here? Now, we won't always have it in vertex form. What we can have it in is what we call standard form. Y equals ax squared plus bx plus c. Because we can multiply this out. But essentially we're taking the x minus h squared and actually squaring it, multiplying it by itself. And when we work it all the way out, we get down to this here. Now they showed this here, and I've included this here to kind of see how the terms work together. But we can say, this allows you to say a is equal to a. B is equal to negative 2AH, and C is equal to AH squared plus K. So A has these different properties, or really, let's just look at the properties of the parabola. Now, the parabola opens up when A is positive and opens down when A is negative. Reflection across the y-axis. Because we talked about the reflection across the y-axis, A's value, because we had inside of parentheses squared, is going to open up, or is normally opening up when it's positive. When it's negative, it's a reflection across the x-axis, so it's making it go down. The graph is narrower than the graph of f of x equals x squared when absolute value of a is greater than 1, and wider when the absolute value of a is less than 1. Well, if a is greater than 1, it's a vertical stretch. If it's less than 1 absolute value, it means it has to be between 0 and 1. It means it's a shrink. Now, the axis of symmetry, x is equal to negative b over 2a. And the vertex is negative b over 2a, comma, f of negative b over 2a. The y-intercept is c. Is the point 0, comma, c on the parabola. Because the y-intercept is the point at which the graph crosses the y-axis. Well, the x value at the y-axis is always what? 0, yes? So if I look at this equation, ax squared plus bx plus c, and I plug in 0, well, I have a times 0 squared plus b times 0 plus c. Well, what is a times 0 squared? 0. 0 times 0 is 0. A times 0 is 0. B times 0. What's the only thing left? C. That would be the y-intercept. Let's go on and actually look at an example. So they gave us this equation here. 3x squared minus 6x plus 1. So before we look at vertex, axis of symmetry, and we can look at the y-intercept, what is the value of A, what is the value of B, and what is the value of C? What is the value of A? 3, negative 6, and 1. Because what is the general form? AX squared plus BX plus C. So we just get 3, negative 6, and 1 just from the formula that it gave us. AX squared plus BX plus C. Now, vertex is negative b over 2a, comma, f of negative b over 2a. Vertex is negative b over 2a, comma, f of negative b over 2a. I removed that so I have a little more space. So let's do the negative b over 2a. And you can write this down below, because we'll actually put the answer right below it, and then we'll do axis of symmetry. Axis of symmetry right below it. X equals negative b over 2a, so x is equal to. And we can fill that in. Now, we'll fill this in here. I kind of put it there so y'all can have at least some spacing-wise so you know where you're going to fill things in. Now, the first part of the vertex is negative b over 2a. What is the value of b? So I can plug it in. 2. What's the value of a? Simplify. Well, we could plug this into a calculator and it would tell me exactly what it is. Well, negative and negative make a. So it's just going to be 6. 2 times 3 is? 6 divided by 6 is? So the x value of the vertex is What about the axis of symmetry? 1. Negative b over 2a is 1. Okay. Any questions on this so far? Probably your big question that you've been wondering is the f of negative b over 2a, yes? Well, the vertex is an x comma y value, yes? Well, if I know the x value of the vertex to find the y, we can do what? We can plug it in. So really, this is saying f of negative b over 2a is really just saying that I'm taking f of 1, which would be our 3 times 1 squared minus 6 times 1 plus 1. And really at this point we could plug it into a calculator, because do we have any variables left in there? No. Because if it's all numbers and I'm not solving for a variable's value, I'm just evaluating the expression, we can do that. Well, 3 times 1 squared is just 3. 6 times 1 is 6. 3 minus 6 is negative 3, plus 1 is negative 2. So the vertex is going to be at the point 1 comma negative 2. The axis of symmetry is at 1. And that's it. That's all we have to do for this here. And if we want to say the y-intercept would be at the point 0 comma what? 1. Because that's where it's going to cross the y-axis. It's at 0, 1. Questions on this here? We have a question, Reed?
Yeah, the last one. For the axis of symmetry, since it's negative in the formula, but b is already a negative 6, would that make it a positive 6 on the numerator? Or?
So when we plug it into the formula, yes. Because our negative 6 would make it positive. Okay.
The negative was not applied to the whole thing. That's what he's trying to get at.
Yeah, so is it just on the top?
It is applied to the whole thing, but as long as we have it on top, bottom, or in front, it still works the same. Because, exactly, negative b over 2a will be the same as negative b over 2a, which will be the same as negative b over negative 2a.
You still apply the negative.
To one or the other, not both. Because if we did this, because we did it this way and got 1. If we do it this way, negative 6 over 2 times 3, well, I'd have negative 6 over 2 times 3. Well, 2 times 3 is...
So the negative outside would apply to the bottom, 2 times 3.
Because here I can leave it out front.
Okay, so you couldn't say negative 6 over negative 6.
No. Because if we applied it to both, so say negative, parentheses, negative 6 over negative 2 times 3, the negative and negative out front would make a positive. So we apply it to one or the other, but the negative would not be applied to both. Does that make more sense? So I normally just apply it to the numerator. Most will just throw it to the top. Because it says negative b over 2a out front. I normally just apply it to the numerator just to make it a little bit easier. Vertex, negative b over 2a, comma, f of negative b over 2a. Axis of symmetry is x is equal to negative b over 2a. Okay. Move this out of the way. Really, for both of these here, it's really finding out what negative b over 2a is. Because once I find that, I get the x value of the vertex and the axis of symmetry. Well, what's our value of b? So just 2. Our value of a is 1. Well, we'd have negative 2 on top, and 2 times 1 is 2. So negative 2 divided by 2 is negative 1. So the vertex's x value is negative 1. The axis of symmetry, x is equal to negative 1. Now we do still need to find the y value of the vertex. Yes? So what do we need to do? We take negative 1 and we plug it back in. Because that's what f of negative b over 2a is. It's taking that value of x and plugging it back into the function to find the value of y. So we'd have negative 1 squared plus 2 times negative 1 minus 1. Well, negative 1 squared is 1. 2 times negative 1 would be negative 2. And 1 minus 2 minus 1 is negative 2. Well, really, the 1 minus 1 is 0, so we're just left with negative 2. Or I can say 1 minus 2, which is negative 1, minus 1 is negative 2. And that's it. Questions on this here? So what's the first real thing we need to find? Is our negative b over 2a. Because that's the x value of the vertex and our value for the axis of symmetry. Negative. The value of b is 2 times negative 2. Well, negative negative 8 is 8. 2 times negative 2 is negative 8 divided by negative 4 is negative 2. And we can plug it into the x value of the vertex and the axis of symmetry. So our axis of symmetry is x equals negative 2. The vertex is negative 2, comma, well, we need to find out what the y value is. And we can find that out by plugging it back in. So taking negative 2 parentheses, negative 2 squared minus 8 times negative 2 plus 1. Now again, we could type this into the calculator and it would tell us what it is. Now negative 2 squared would be positive 4, because negative 2 times negative 2 is positive 4. Negative 8 times negative 2 is going to be plus 16 plus 1. Negative 2 times 4 would be negative 8. 16 plus 1 is 17. This gives us 9. Questions on this here? Any questions on how we got the vertex and the axis of symmetry? I believe we have one more like this, or are we moving on? That was it? Okay. Almost. Now, we've talked about this before, but y equals on the graphing calculator will let us graph a function. Yes? Because we went over that either in here or in ACT prep. Okay, good. -2. Come on. X squared minus 8x plus 1. So really all I've done is I hit y equals and then just type the function in. Now I cheated a little bit because it was already typed in. Once you get that typed in, go on and hit graph. It graphed it for you, didn't it? That's why I've been saying I don't think really learning an in-depth way to graph these is as important as it used to be, because that thing will graph it. There's a Desmos will graph it for you. We have this here. Well, what did we also learn? What is the axis of symmetry for this function? X equals what? -2. So I know also the vertex is at -2 comma something, yes? Hit second graph. Well, we said the x value was -2 and the y value was 9 for the vertex, yes? Did the calculator just give it to us? And we also said that the axis of symmetry, x equals -2, that all the other points mirror each other from that line. What's the y value one down from the vertex? 7. One above it? 2 below it is. 2 above it. 3 below is -9. 3 above is. 4 below is, what would be the one above -5? So again, the axis of symmetry, it mirrors it across, yes? So we should expect this to occur. Graph.
Calculator. Oh, I see.
Yep. Now,
My numbers not look like that.
let me see.
Okay.
Yeah, because when we put x in,
I was wondering why it wasn't graphing.
yep, -2x squared minus 8x. Yep. So one of the other things is, and I'll address that right now, the leading coefficient, so the number in front of, so x squared is the biggest one we lead off with. If it's negative, we use the negative sign. From then on, like in front of the 8, we would use a minus sign. Now the graphing calculator is not going to throw a fit if you do -2x squared -8x. It's going to say that's fine, okay. So what you're telling me is that I have -2x squared times -8x. it's going to consider that multiplication and move on, not subtraction. So we do have to be careful with that there. Now I'll show you one other thing before we move on. If you go second trace, how it says calculate in blue, and it'll pull up calculate. Well, say we want to find a value for this function. Go on and hit enter. Well, we found what value of the vertex was -2, yes? So I could tell it -2. We're saying x is equal to -2. Hit enter. Y is 9. I could do that again, say second calculate value. It says given the following function, find the value of when x is 10. What's the y value? Well, we could have found that with the table, because the table does whole number values, yes? So let's say -3, well, 3.85671. Because that's definitely not on the table, is it? And if I hit enter, the y value is 2.105256. It was calculated for us. Okay. Let's look at the next part. Now, this is already filled in for you, I believe. Nope. Okay. Let's get the highlighter out. Highlighter. On both of these here, the domain is all real numbers. And really for most functions, higher degree polynomials, the domain is going to be all real numbers. Because the domain is the values we can plug into the function itself. Because until we hit rational functions and radical functions, really the domain is going to be all real numbers. We can plug anything in. The range in minimum or maximum value. Well, this f of -b over 2a, well, that's the x value of the vertex. The vertex is going to be the maximum or minimum value depending on how it opens. Because for this here, when a is greater than 0, it's opening up, yes? So no matter what point I pick on the graph going to the left or to the right, there will always be a point bigger than it. No matter what point I pick on either side, there will always be a point greater than whatever point I pick. However, at the minimum, is there ever going to be a point lower than that? No, because either side of that point is going up. So it's a minimum value. And really, it's just whatever the value of the x value of the vertex is. And the range is always going to be greater than or equal to that value. So if a is positive, it's going to be opening up, and its vertex is the minimum. If a is negative, it's going to be opening down, so the x value of the vertex is going to be the maximum, the point where the maximum is at. And the range is going to be y is less than or equal to whatever that y value is. The maximum, again, it's really focused, not on the x, but on the y, whatever the y value is. So once we find the vertex, we can really tell it's okay, the maximum value is this, or the minimum value is this. The range is going to be greater than it or less than it. Increasing, decreasing. So we're going to look at one of these here. Find the maximum or minimum value of this function. Describe the domain range of the function and where the function is increasing and decreasing. Well, the a value for this, is it positive or negative? Positive. So will it have a maximum or minimum value? Mm-hmm. Let's actually look at this another way. Y equals. Clear that out. Let's say alpha y equals enter. Come on. I know you're here somewhere. There we go. Because I want the 1 over 2 x squared minus 2x minus 1. Once you get that typed in, go on and hit graph. Once you type that in, go on and hit graph. Is it opening up or down? So will it have a maximum or a minimum value? Minimum, because there is a lowest point, but there is not a highest, so it has a minimum. Yep, it's just been moved. Yep. So we can say it does have a minimum value. It would be nice to know what the minimum value is, isn't it? Well, we can use the negative b over 2a, yes? To find it. Well, since we're still doing this here, second, calculate, because it'd be nice to calculate this, yes? It'd be also nice if it actually had a minimum function. Or does it? It does, doesn't it? Minimum. Enter. Now it says left bound. What this wants, the calculator, what it wants you to tell you is to pick a point to the left of where you think the minimum value is. Is it the flashing little X to the left of it? You said enter. And now it says right, yes? Now we want to go to the right of it. So we can use the right arrow, and you see how it moves it? So once we've gotten to the right of wherever the minimum is, wherever this is going to stop, there we go, hit enter. Do you see how you kind of have two dotted lines? What it's telling and what you told the calculator is on the graph between these two lines, there is a minimum value. Now it's saying guess. It's saying, do you want to guess what the value is? I'm going to say no. Just hit one more time. So the minimum value is at 2, negative 3. The point 0.0000001315. We're not going to be concerned with it. It's really 2, negative 3. What it's calculating in is the pixel error. Is that there? Now, if we go back to the other one, here, well, if I do negative b over 2a, negative, well, the b value is negative 2 over 2 times 1/2. Well, negative 2 is just 2. What is 2 times 1/2? So the x value is 2. We can plug it in. 1/2 times 2 squared minus 2 times 2 minus 1. 1/2. 2 squared is 4. Negative 2 times 2 is negative 4 minus 1. 1/2 of 4 is 2. Well, negative 4 minus 1 is negative 5. 2 minus 5 is Wait a minute. Isn't that what it told us? It gave it to us. So that took care of the minimum value, because our minimum value would be, our min is really y equals -3. Because if we look back here, minimum value, f of negative b over 2a. So the minimum value is our, what do we just say, minimum of -3. Describe the domain and range. Well, domain is all real numbers. It's going to be all real numbers. It's a quadratic. Range. Well, if we look at the range, y is greater than or equal to, because the value of a is positive, it's going up. It's everything greater than or equal to what? -3. Increasing and decreasing. Okay? Do we have this down before we look at decreasing and increasing? Now, we can look and see what is the picture, or what is the kind of textbook definition of it. By definition, it's this increasing less than so on and so forth. But whenever we look at this, or whenever we read a book, we always read from left to right, yes? So as I'm looking at this, coming from the left, what are the points doing here? They're going down. So this here is decreasing from -infinity to, so where is this spot where it stops? Well, the x value is at 2. So really this function is decreasing from -infinity to 2, where at which point it becomes increasing from 2 to infinity. But that's it. So we'll finish this up tomorrow. I did not plan on us finishing it today.